So today we're going to look at some samples from the VCS-5RT that was done in August 2021. These were extracted scale samples from 9th of August 2021, and this is the balance of the material in here in this sample container. This bag has material which I extracted some magnetic components which are in there. You can see those kind of black things at the bottom of this container here. There we go. So here is my little neodymium cube magnet. We'll see if any of this gets affected. Oh, I can immediately see there's some stuff moving around. Okay, immediately. Okay. Now, all right, this is interesting. So, wow. Now, the thing is, whilst a lot of piping in the system is copper, I think the initiation of the heat generation system is actually using steel, the actual injector where the multi-phase injection is going in. And so if there's cavitation at that point, it could be extracting some steel. But wouldn't it be absolutely incredible if some of this material has iron-rich crenellated microspheres? Incredible or not? I don't know. Right, I'm going to get a big boy magnet on this, and we'll see what happens. So here's an ND52, and we'll put it over the white stuff, and we'll see what happens. Okay, there we go. Oh, there's a lot of stuff in there that is clearly magnetic. Now, are these the magnetic core of fractal vortex solitons? I don't know, but what I will do is I will extract some of these and we will have a look at them under the microscope. But clearly there are a lot of material in there. Let me zoom in so you can see a little bit more what's going on. Look at that. That is a lot of material in there that is attracted to the magnet. And we're going to put that on this sample stub over here and have a look at them under the Hitachi TM3030 Plus SEM. Here onto this sample stub over here, and this is basically just a plastic bag which has been cleaned off, and we're going to transfer that over hopefully without any too much of a problem. Okay, so I'm going to take this off here, so that is now clean on there. I'm going to hopefully tip these out onto here. And they are now on there. And just move them into, spread them out a bit because they're just basically a lump at the moment. What are these magnetic particles that we have extracted from this cavitation reactor from Bin-Juine Huang? What are they? Okay, so they are on that stub now, and we're going to put this in the microscope. Here is the material on the SEM, so you can see it there. So at the moment it's trying to evacuate the chamber. Hopefully it will get there. It seems like it might have done. So in theory we should be able to do a sample. So start. I don't know where. It's doing its calibration now. Auto start process, so it's found some things. So what have we got from the inside of Bin-Juine Huang's cavitator? These magnetic particles, what are they? I'm using the hand controls, as is what you need to do on this Hitachi TM303 Plus, to have a look at these iron-rich particles. Let's see what we have here. So we're getting into the bulk of the area here. What are they? Well, there's something that looks a little bit round there, so we should maybe have a look at that. We'll go in a bit. What is this? Let's try an autofocus on that. That's not really done it, has it? Am I getting more? Not very much in focus. It's getting there slowly, maybe. What is this little round thing we have here? Is it going out of focus there? It's out of focus, coming into focus. What is this? It's a nice and little round little particle. Look at secondary electrons here. Backscattered here. Can't see a lot there. The autofocus is not great today. Not getting a lot of joy here. What have we got here? It's a ball of something. But a ball of what? It was magnetic. Is that a sphere that's been rounded off? Don't know. I think we should find out what it is in terms of elements. I think that would be a good idea. So I think we'll take an image here. See what the settings here. Settings for save. Save image. Need to change the images on this. So this is VCS-5RT VCS-5RT, and I'm going to put MG for the magnetic samples. I'm going to say this is 001 set. So you can see that changes that down here. And I've got that to auto increment here. And I'll add the comments here. This is the magnetically separated parts. Set save magnetically separated. Just set parts. Okay, all right. Set date. Okay, everything there. Save. Okay. This is a large sphere, by the way. It's 100 microns. So it'd be interesting to see what this actually is comprised of. Okay, so I'm going to save that. So just to show this, there we go. That is the image there. And was this ever a crenellated iron-rich sphere? I don't know, but we're going to find out. So what I'm going to do is I'm going to capture over here. No, that's, I need to go to 15 kilovolts, don't I? Maybe I can go into the edge here, for instance. Or here. It's definitely becoming unfocused. Okay. I'll take a image of that. Does look like it's segmented. Now we see it with this higher beam energy. But has it been rolled around so much? Don't know. Let's see how this appears. Okay. The elemental changes. Now, is this a heavier element? This could be copper here. Maybe this is iron mostly, and then these are carbon or silicon deposits on here. Who knows? We shall see. So we're going to stop it. I'm going to switch to EDX. Okay, so this is now on EDX, which it's got the maximum beam energy here. It's probably 20 kilovolts or something, and it's produced quite a nice image. So we'll actually take a grab of that. Yeah, you can really see the segmented sections here now on this. We will switch over here and we'll do a capture again. And we will delete or select or delete all. Okay, so I need to rename this as well. Okay. So we'll change the sample name here to VCS-5RT magnetic particles. Okay, so capture that again, and then it changes the name down here so that the images have the correct assignation. Okay, so now we should be able to get a better number of samples per second on our analysis. So we'll go back there and we will go and choose this one, and this I think probably might be copper. We'll see. Something higher anyway, and we'll go acquire. So as I predicted before, iron, silicon and carbon, and obviously with the oxygen. That's Windows Photo Viewer, looking at this rather lovely iron-rich sphere. That, oh yes, you can see the crenellations here. Beautiful, beautiful. This means that Bin-Juine Huang system, at least at this stage, is producing iron-rich crenellated spheres, and this is over 100 microns, so it's equivalent to the cavitation system of the original ultra experiments as conducted with aluminium by Alan Goldwater. So this has been rounded off, but you can see the divisions of the crenellations here, and maybe when we play around with this with a bit of contrast, those will bring out to be a little bit more clear. So these are 3.82 thousand counts per second. Very, very clear signal here. Very, very clear. Carbon, oxygen, iron, silicon. A little bump here. Okay. I guess it'll go through and do the other ones there when it's ready. Ah, for some reason I clicked that again. Oops.
So what's happened is the beam turned off over here because it was in freeze mode. So I'm going to capture this again. So I'm going to start at 1 now. So it actually has the number, and I'll capture this again. Half a million counts on there. Do real time 100 seconds. Okay. And we will go bump. No, needs to select something. And then we'll go bump. And then we will go bump. So firstly, we will select that one. Okay, let's dump that to a report. We will select our next thing, which is this one. So the second one, again, lower iron here, far higher carbon and oxygen. So yes, I was correct about that one. And then the third point we're going to look at up here. Let's see what we have here. And this is the one which has silicon in it. Okay, but the main structure of it is essentially iron and oxygen with a little bit of carbon, our classic iron-rich crenellated microsphere. Here, again, in the Bin-Juine Huang VCS-5RT. So yes, this one has silicon in it, but otherwise it has iron, oxygen and carbon. There we go. So I think we should probably go and look at another area, don't you? So let's go back here. And we'll move around on the table. Let's see what else we can see. Ooh, is that an iron-rich? Oh, there's an iron-rich crenellated sphere that's split. Maybe. Look at this one though. This little puppy here. We go in a little bit more. I think we might get to see, it's got a little baby one off to the side, look at that. Yeah, you can see the crenellations here. Pretty sure this is going to be mostly iron as well. Yeah, look, you can see the divisions here. 1, 2, 3, 4. They're probably the classic kind of size. This is 20 micron, 10. So these would, yeah, so it's classic sort of 1 micron divisions. So classic sort of 1 micron divisions. See, 1 micron, round about a micron, just over a micron. There we go. Same, same, same. Let's go over and capture that over here. Clear those. I suspect this is going to be iron. You can see the crenellations on this one as well, but I suspect it's going to be iron. So we'll go there, and we'll have a look at this little one as well. So we'll have a look at those two. Acquire. Aha! So yes, this is broken up a little bit, and we can see we have some chromium in there. And of course, chromium actually is quadruple carbon, actually. So if you take carbon and fuse it, you get magnesium, 24. And if you fuse that, you get chromium, 48. There we go. Now, we saw chromium also in the crenellated spheres on the outside of the inside in the thunderstorm generator, the 24-inch sphere. And that is assumed to be because of the capture of chromium from the base steel. But maybe it's actually 4 carbon atoms fusing. Maybe. So here you can see there's even the crenellations on this one here. Very clear crenellations here, but maybe because it has some chromium in here, you don't get the perfect kind of structure. Again, here this smaller one has a small amount of chromium in it. Otherwise, it's the same iron, oxygen, and carbon mix. Okay, so we will go and have a look at some other areas. So large chunks of this are conglomerations, it would appear. Oh, look at that up there. What is that? What are those little things there? This looks like a hollow one, which has been then filled up. Okay, so this here is typical, in my view, of something that is got some impurities in the iron. So I'll have a look at this, and this looks like the carbonaceous and silicon type of accretion band rolling around the outside. Let's see if we can get in there closer and focus on that a bit better. There we go. Look at that. That's nice, isn't it? So I would imagine this has a little bit more chromium in it because of where it's not perfectly meshing together. Okay, so we'll take a screen grab of that, or a photo, let's say. And this one over here, you can definitely see the crenellations in that. And normally the crenellations are a layer, and then it has a coherent layer on the inside. But this one's cracked and then filled up with rubbish. Yeah, definitely you've got some skim around the outside. It might be difficult to capture it on this one, unless we go here. And I expect that to be higher in silicon and carbon. Okay, so we'll take that and we will capture that over here. Yeah, I suspect this will be higher in iron and oxygen. This looks like a more pure one, and then this one looks like it's got the chromium contamination in it. Now, is that because it's synthesized chromium, or it's actually stripped it out of some steel? Let's find out whether I'm on the money. I want to take that, and then I want to take this bit here. So we will go there and there and acquire. So that's interesting. It is a different element, but it's sodium. It's seeing there. So actually, it's got a lot of different peaks. Why is it not detecting everything else? Let me see what's going on here. Oh, I've got fixed elements. It's auto-detected those elements, but there are definitely other elements here. What are they? What have I actually got this on? I think I need to do some quantify here. There's definitely other elements here, I would argue. Seeing the sodium, but like, if I have to put magnesium on there, you see magnesium looks like that line, right? Aluminium, yeah, looks like that line. Silicon is that line, and is that phosphorus? Yeah. These are the usual suspects you get. Now, have we got sulfur as well? Yes. A little chunk of sulfur there. Yeah. Neon, is there a blip there? Maybe there's a shelf on that. It does appear to be a little shelf, but we wouldn't expect it there. Nitrogen, yeah, it's got all of the elements. What have we got here? Is that boron? No, there is no boron. Beryllium? No. Yeah, I'll put it in there. No, it's not there. Potassium. Not really. Calcium. Yeah, we got calcium, of course. So this is the kind of material you'll get orbiting around these structures, which has all of the elements for life in there. Now, what is this? Is this? This might be chromium. Yeah, there's the chromium peaks. And it's even got the chlorine peak here, maybe? Yes. Just subtly. Is this one? What is this one? What is that one there? No. No. Could be titanium. Is it titanium? No. No titanium. Manganese? No. No manganese, I don't think. Oh, it's not the cobalt. I think we got everything covered, haven't we? Oh no, it's this line here. What is that line? Not zinc, although we might have zinc in there. Don't think so. Copper. Is it copper? Well, there are copper pipes in there, so wouldn't be surprising. But we have all these other elements here, not as significant as the iron and the oxygen and so forth, but still. There we go. So that is particle 7 here. What is yeah. Actually, you can see here it's auto-determined at the end here. All of those elements that I've just found here. Can I zoom into that? You can see here, so it's automatically determined sulfur, carbon, oxygen, iron, sodium, magnesium, aluminium, silicon, phosphorus, and iron, and it missed the copper peak here, so it couldn't determine that fully. Other than that, I think it pretty much got everything that we determined here. It's not seeing the chromium, it's seeing that as oxygen. So maybe that actually isn't chromium in this case. It's the oxygen line. Okay, so it's no chromium there. But otherwise, all of the elements you typically see synthesized in cavitation processes from other authors. So let's see what this one finds relatively. And we'll go acquire. Turn off that one for now. Yeah, so it's just not, it's definitely seeing the chromium that time. Yeah, not really seeing the chromium here, is it? I mean, it's there, but it's not really there. But here, interestingly, it didn't find the calcium peak here, which we determined there. And there's no calcium on this particular one. It's essentially iron, chromium. Yeah, so this definitely has the chromium in it. And that's what we're now recognizing is producing these non-perfect crystals. Now, the question is the chromium coming from fusion of 4 carbons? That's the question. Or is it being ripped out of steel? I suspect when we look at this one here, it's going to be more pure iron and oxygen, because this looks more like our iron-rich crenellated spheres, and it's going to be full of carbon. And of course, these structures produce carbon inside them, don't they? You see it in Matsumoto, the erupting carbon from inside. And is this a load of carbon that was synthesized inside? And I mean, predominantly carbon, but will we find other stuff when we look at that? So it's done its job over here. Yeah. So there's the answer. It's assessed there to be iron, chromium, and oxygen and carbon, and hardly anything else. And I suspect we're going to look at it. This will be essentially just iron when we look at that, and oxygen. So we'll go and do that now, shall we? Just move that over there. I suspect all of this in here is going to be mostly carbon. And this is basically seeing the inside of an iron-rich crenellated microsphere. Look at that, it's lovely, isn't it? Wow. How beautiful is that? We'll try and capture this edge nice and crisp if we can. No, not like that, we're not going to. Definitely an iron-rich crenellated microsphere. I'll take an image at that resolution and then we'll just dial it back so we can see the whole thing. Beautiful, well done Bin-Juine Huang. Confirmation, it would appear, of the same process going on in your 2021 VCS-5RT reactor with the iron-rich crenellated microspheres that are hollow. And so we'll just come out of that a little bit so that we can see the whole thing. And maybe we'll come out so we see all of these three little items in the one shot. How about that? That's rather nice, isn't it? I'll take a shot of that. So the one that looks like the more pure one is this central one, which is hollow and has broken up and has revealed a mass of material inside, which I believe will be a range of elements, predominantly carbon. Okay. Okay, so we will switch over here and we will click here. What a beautiful thing. What a beautiful thing. So we are going to have a look at the surface of this one here, and maybe where, let's say there. And we'll have a look at that on its own right now. I suspect this is mostly iron, oxygen, and carbon. I rest my case. Look at the amount of iron in there. Be interesting because we got it here to see what this area here is on the edge, if it doesn't glance, because it might get whatever this is and whatever the back this is. We know this is carbon in the background, but it might get some of this reflected. But let's see, because this might be even higher concentration on the actual split plane. But whatever it was in here, maybe this was the pole and it burst out of there. The emerging elements, the newly synthesized elements. And this little seed, this seed of life, flower of life. Just for the record, to have a look at it whilst it's doing its sampling there, we'll have a look at that image. There it is. What a beautiful thing. Look at the crenellations on that. Absolutely stunning. And the distance here. "50 microns across." Beautiful example of the process in action. 35% iron. Let's see if this is even higher when we're looking at the split plane here. So we will select that and go require. Is it higher than 35% iron? No, actually. It's 20. There we go. The carbon content is almost exactly the same. But here we go. It actually looks like very high concentration of iron and oxygen. Now the interesting thing is going to come when we look at the inside of this, and I think I'm going to do a map of that because I want to get a full idea. We'll zoom into that area. I want to get a really good idea of what that is. What does it entail? I want to understand what that is. So I'll do a couple of sample spots in here, but I predict that most of it is this range of elements, but skewed to carbon. Yeah, so the story comes out: calcium, carbon, oxygen, iron, copper, magnesium, aluminium, silicon. Right, so we're going to zoom into this area here and maybe do a map. I'm pretty certain we can conclude that that is an iron and oxygen crenellated microsphere. This is the best example we've had of a split one, and then looking into what the guts of one of these structures is. And you can imagine the same sort of thing happening with Alan Goldwater's one, where it's split out, and we just got a section, a triangular section of it. However, we didn't see the contents, and you can see that the contents is separated. If we go and look at the image here, and how should we open with this? You can see that actually this is separated here from this inside area. So you can imagine if this whole thing blew up, you would have a section of the shell like we saw with Alan's, and the guts had fallen out. Isn't nature a marvellous thing? Okay, so I'm going to go here, and we are going to zoom into this because we want a better look at it. And we'll go down here, up here, across here. Beautiful, absolutely beautiful. Thank you, Bin-Juine Huang et al. So we are going to, I'll take a little adjustment of the contrast here. See if we get something more interesting on the secondary electron. Shows more of the topological effect. Right. You see this charging going on in here. This might imply that there is some silicon content in there. Down here you can see we've got the charge up reduction on here, but it's still got some excitement going on the edges here, some charging up and some charging up on probably the silicon rich areas in the center there. So we are going to look at this under the SEM+EDS in a second here. This time I'm going to look at doing a map of this area. Wow. Are you seeing what I'm seeing? Are you seeing what I'm seeing? Calcium here on the inside. Calcium. Of course, it's seeing the bulk elements there. Now we know from the previous look at this that we have magnesium, silicon, aluminium, as well as calcium in the center here, but it's really picked out that the center core here is calcium in aggregate. Well, I'm going to pause the recording because it's just going to be doing a lot of sampling now. Okay, so very clearly we can see that it is iron, oxygen and carbon, but carbon in this splodge here and in this splodge, but also carbon in the center. So predominantly the center of this is carbon, oxygen and calcium, and this is essentially just iron and oxygen. Okay. Now, because there's so many samples at this point, it assesses those. So I think what we'll do is we'll go into this area here and do a more detailed sample. The interesting thing to note here is that it does appear that this inner section is made up of a whole bunch of toroids. Okay, and I'm wondering if these toroids in here are these structures that we see, these calcium and oxygen structures, and they somehow aggregate together, and that they are the magnetic charges that come together and then produce this overall structure. So we're going to have a look a little bit closer into these as we go forward.
Okay, so you're running a map now?
I'm running a map, yeah. So that was the first one I found,
Yeah.
and I couldn't see, but it did look like it had segments. But this is a very large one. This is like the one that some of the ones that you produced, but it looks like it's been rolled around.
It's messy, yeah.
Yeah. But then when I was going into it with slightly different, oh, is that going to allow me? Oh, here. You can actually see here, you've got the crenellations there.
Starting, yeah.
And it's the same thing, but it's like it's been smoothed off. It's like bowl milk. Now here you can see them here,
Yeah.
right? And in this one it starts to become really clear.
Yeah.
But still, it's been affected.
It's got something deposited on
This
the
one very clearly. So this is 20 microns. That's
Yeah.
1 micron. Like, sorry, yeah. So
It's a big piece, isn't it?
yeah. It's still, this is 20 microns, but it's quite common.
Yeah.
This one has the chromium in it, so you end up with these broken crystals. But this is when I saw this one. Like, I mean, I've not been looking around it much,
Yeah.
but you see how it's got these kind of ring-like sections,
Yeah, I know.
similar to the bit that you analysed, but from.
And what's the core made of? Is there carbon in there mainly? Or
It's
what?
mostly carbon. Yes. Yeah. So here. So I'm just looking at this spot because it's a bit lighter, but it's got iron, magnesium, aluminium, silicon and phosphorus.
Yeah.
The usual suspects for the broad spectrum of things that get produced.
Uh-huh.
What's going on? Why is that being slow? So where is it?
And the sulfur's starting to pop up too.
In places, yeah. So the skin here, whichever one this is, 8 here, yeah, the skin, 35% iron, 15% oxygen, and the balance is carbon.
Yeah.
And here, a similar kind of thing, but inside, iron, copper, magnesium, aluminium, silicon, calcium.
And iron is mostly single isotope, isn't it? 56, is it?
No, I don't know. That's what I want to do now.
Yeah.
When I wanted a reliable source of these things,
Yeah.
so like I've got obviously a lot, because out of that bit I got, without much effort, I got quite a lot of material.
Yeah.
So yeah, it's highly satisfying.
Uh-huh.
Actually, in here it's got aluminium, silicon. You can see, but it's only in this part. Like,
Yeah, it's diffused.
yeah, it's not much data on here. On these ones, they're very low sample rate.
All right. And the grain and the phosphorus is because the percentage is so low.
Yes, but it
Right
kind
at the
of,
threshold of detection.
yeah, but it's definitely got silicon, definitely got aluminium.
Yeah.
The iron is in the core to a degree, but it could be contamination.
Yeah.
But the calcium's everywhere in there.
Uh-huh.
Yeah, so very, very, very interesting.
Uh-huh. And how big is that one? The broken one?
That one's 50 and a bit micron across. It's in the sort of scale of the ones that you were finding.
Yeah. So visible to the human eye, barely, but
Yeah, you can see it as a circle. So I'm then there's this agglomeration, and I'm wondering if these agglomerations are like a lot of stuff that's come out of a broken one, like this stuff.
Yeah.
This stuff has come out, and it's in here, but it's got mixed iron in there. So it is magnetic. See, look, I think when I look at these, I'm going to see that same kind of pattern that you saw with these toroidal kind of clusters, and it's just a whole agglomeration of it.
Yeah. Yeah, that's a big chunk there, isn't it?
Yeah, yeah, it's very big. Yeah. So there's.
And did you scrape that off of the?
He scraped it off.
material? Oh,
Look
okay.
at it here. I mean, this is this kind of structure.
Yeah.
Look at that. That is definitely got some sort of a fairly regular kind of form to it.
It's lots of little chunks of micron-sized particles.
Yeah, yeah.
But they could stick together from.
Yeah,
You know,
there's a range of different
forces
ways.
and
Yeah,
stuff.
all kinds of different ways.
Yeah.
Like here we go. They've got some more up here. So like they're all over the place.
Look at that sharp edge there.
Yeah,
It's something fractured that's got
yeah.
a lattice kind of structure to it.
Now that might have built up on the inside of, say, the copper pipe and then broke off. So you're seeing one smooth side, but
Well, zoom in on the fracture line.
yeah.
See, is it fractal, or is it actual?
Oh no, this looks like the inside of your ball. Your fractured ball. Okay, I mean it's going to take some time to have a look at it, but
Yeah.
anyway, there's plenty of these balls around.
Yeah. All right. Well, just
Yeah, I'll do what you say. Yeah,
stop the gun.
yeah, yeah. Thank you, Alan.
Yep.
So we'll have a look at this bit here. I think this is going to be silicon, but maybe it'll be iron. This will be interesting. Oh, maybe it does have some crenellations, but it's been highly smoothed. Let's see what we can see. Yep. Of course, could this be the pure iron sphere with the crenellations broken off it? That would be interesting. 20% iron, that's by atom percent. So if I go to mass concentration here, it's nearly 50% iron. Yep. That is over 51% iron. And over 40% oxygen with a little bit of carbon. By mass. So we'll have a look at one of the other structures there. Later we will look at these agglomerations, these magnetic agglomerations. There we go. Yeah. What a lovely thing. Pretty sure we're going to find that this is iron rich. Lovely, absolutely lovely. Okay, let's see if it is what we think it might be. Well, it's not getting many photons there, but it is 51% iron and 32% oxygen there. Yeah, not a lot of counts per second. It's okay, I guess, but same result though. It's in a hole, so it's not so good. Anyway, let's have a look around a bit more. There's another one there, totally buried in this incrustation over here. The question is, are these incrustations the magnetic core of other material? Of other yin-yangs or whatever. Yeah, I think big flakes. Like the worst progressive digital camera. Progressive scan. It's really slow. Oh, there's one right at the end there. A hole. Bit stuck to it, don't know. Again, they're very smoothed off, many of these. Right, well, there is a good selection, isn't there? Look at that. It's as big as I can go, really. But just in this frame here, I can see 1, 2, 3, 4, 5, 6, 7, 8. Quite a lot just in that frame. over here just lurking around? No. So a reasonable proportion of the magnetic material is iron-rich crenellated microspheres. Okay, so we'll have a look at this one up here that's all nicely isolated. Actually, we'll look at this one whilst it's in nearly the centre of frame first. It's a rather big one. Yeah, it's kind of squished. That's interesting. Look, it's got a triangular section knocked out of it. Ha 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 ha. Just like Alan found. There we go. A couple of sections knocked out. Really clear triangular section. Right. Was this the first one we looked at? Can't remember. Maybe. It might be. Yeah, it might be. So these large-scale cavitation systems do produce the very big structures. This is, I would say, around about the high 100 micron mark, which is similar to that observed by Alan Goldwater in a cavitation system. So there's one over there, isn't there? Which is a smallish one. Then after the break, we'll come back and look at the other sort of material that's in here that's meant to be magnetic. This one probably is contaminated with chromium because it looks a little bit not so round. Less than perfect. Yeah, it looks like a contaminated one. Yeah, we got the triangle hole cut out of it. So I think the big win on this particular sample was our one that had, in fact, it looks like there's a lot of balls in this little area here. Yeah, look at that. It's full of them. The whole place is full of them. Oh dear. Can you see what it is yet? Yeah. So possibly the agglomerations that you see might be cavitation that didn't really do much. It just captured a bit of iron or produced a bit of iron, and it forms this agglomeration. I mean, is this an agglomeration occurring here? Like, for instance, that. Be interesting to see what that is. That almost looks like loads of the crenellations that have come off another sphere, but they've linked together. Looks like quite a few triangular pieces there as well. Look, triangular, triangular. Is that a triangle, triangles? Don't know. Let's have a look to see what that is, actually. Let's see what that is. Interesting morphology. What is it? I don't think that's palladium. No, it's not palladium. It's not getting a lot of counts. The beam is not seeing it. Why is it not seeing it? It's not palladium. Can't be palladium. Carbon, oxygen, iron, silicon, copper. Okay. It's got a big chunk of copper there. That's why it's a bit luminous on the BSE rather. Question is, why is it magnetic? Well, it has some iron in there. Is it being swept up with all the other magnetic materials, possibly. That is that. Fair chunk of copper in there. Yeah, it's definitely got copper. It's got the secondary peaks there. Okay. Interesting. What is that? And what is this? Let's see. Well, it's this mass of different elements. It has copper in there. It has aluminium, silicon, iron, calcium, carbon. Usual suspects. Looks like it might also have some magnesium in there as well. Just under the 1%, so it doesn't pick it up. Just under. And is that phosphorus? Yes, phosphorus here. Again, the phosphorus is under 1%, but the signal's there, and it also looks like it's got sulfur there, but it's again not very big signal. So this looks like it's the synthesized material. Now, is the white stuff there iron rich or is it copper rich? This actually has, by mass, 14% copper. Yeah, it's more copper rich. So Is it? Yes, much more copper rich. It's more iron rich. And it's not showing the other elements there, is it? We put on aluminium and silicon and phosphorus and sulfur. No, there's no sulfur there. Chlorine, no. What is this peak? It's got the magnesium. Very low levels. Sulfur is just not there really. Oh, similar level, but not really. Calcium on, yeah, it's got calcium, but again, not the same level. That's looking at the same kind of elements. But if you put it on, definitely the grayer stuff has a higher concentration. The question is, are all those elements coming from an interaction with the copper? Is the copper a food in this instance? Maybe. Maybe. Well, we'll have a look at a little bit more of that in a while. Okay, so that was the first ones we looked at. Well, it's all pretty similar, this stuff. Let's have a look around the extremities. Yeah. Very irregular one here. Some hair fibre there. Slightly unusual morphology on this one. Slightly different. It's almost like it's a ball made of fragments that came off another ball. Let's see what it's comprised of. Well, there we go. Iron and aluminium in this case. Interesting. This is unusual. Slightly different from the norm. Clear aluminium peak there, and silicon too. Very unusual, this one. Has that significant amount of aluminium in it. Okay, the results there, 2.14, but in atom percent, if we go here and do atomic concentration there, actually it's not that much different. 1.25%. Normalized mass concentration. 35.52 iron, 1.77. Well, there we go. Is there more than one like that? No, that is a little bit special, that one. Some random bits here. Yeah, I think that is that sample now. Now there was one very smooth looking sheet of material that we saw. Let's have a look at this one first. Usual. Where was that? There. What is that? Although it's hidden, it's going to be difficult to assess. What is that sheet there? That looks like the inside of one of these balls from Alan Goldwater. So I think what we'll do is we'll do that. See if you can get the focus a bit better. No, I think that was pretty good. Save that.